Hello everyone, welcome to the fourth module of Trigonometric Functions and Relations of class 11. As we have seen already, sine cos square x plus sine square x equals to 11 and everything is there. We've learned about all of these, right? We've learned about all of these and why it is cos square x plus sine square x. There are certain questions that still linger in our minds. So first one was this, and the second one would be how and how the hell these things are true, right? Cot square x and sine square x are true. These two equations are true, and how do we uh, you know derive this table? Hmm. They are very yeah, they are very important questions that we need to answer. So a square plus b square equals to 1 plus cos square plus sine square x equals to 1. What if? What if the circle ka radius is 2, right? What if instead of 1 it was 2? Let's assume. Because it's 1, we can say that. No, for this, I would recommend you watch part 2 of this series. Yeah, we had explained why it is like this, right? So we'll cut this out and make this 2, right? What if it's 2? So then cos x will be cos x, that is a, will be a by 2, right? And sin x will be b by 2, right? Then how do we make sense of this, right? How a plus b square will be 2 square? Let's find out then. So we'll get on to draw chart. If you don't understand why it is a by b, a by 2, please watch part 2 of trigonometric functions. Please watch part 2. In that we have in detailed explained all of these topics. So these series are for really, you know, weak students who are not able to cope up, because 11th is a big step from 10th, and I understand that, right? We will, you know, go through this together. So please watch part 2, right? So A2 by B2. Let's find out. I don't usually tell watch this video, that video, but now I'm going to tell. So it's A2 by B2. So what is the Pythagoras theorem? The Pythagoras theorem is this. Right? A square plus b square equals to c square. Right? Not this, sorry. A square plus b square equals to c square, where ABC is any, don't think about this triangle, don't think about this chapter only, okay? Let this chapter drift out of your brain. So where uh, you know ABC is any triangle, and A is one side, B is one side, C is the hypotenuse, and this is 90 degrees, right? So A square plus this square, right? This side ka, if we take out square, will be equal to this side ka square. Simple, 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 right? Simple, simple. Okay, we got onto the wrong page. So we'll erase all of this. So that is the Pythagoras theorem. So according to the Pythagoras theorem, what will we do here? What will we do here? It will be this side plus this side and this side, right? What is cos x? Cos x is this side by this side. Then uh, sin x is this side plus this side, right? So what we get is we get two equations here. What we get, a square plus b square equals to 2 square, right? How? How a square plus b square equals to 2 square? Because this is a right angle triangle, and A and B are the foot of this triangle. Thus, a square plus b square equals to 2 square, which could be also called as c. It could be called as c square, but then we are calling it as 2, right? So then we'll get it like this. We can get it like this, our answer. And then we'll get the what we'll get is a square plus b square is equal to is equal to 4, right? So that means a by 2 and b by 2. That is, a by 2 is cos x, and sin x equals to b by 2. So what we get is this, right? So let's say that we take cos x square. Let's say we do this plus sin x square equals to, we find the value, right? So it will be a square plus b square, and down we'll have 2 square, and we'll have 2 square. 2 square is nothing but 4. 2 square is nothing but 4. So we get 4. So we'll erase this. 2 square is nothing but 4. So we add this. We don't know what the answer is. It could be cos square plus sin x square, could be uh you know anything. Let's find the answer. So it'll be a square plus b square by 4. So we already have a equation. A square plus b square is 4. Nothing but 4. So 4 and 4 will get cancelled, not cancer, get cancelled. And the answer is 1. Haha. So from this we can prove that it doesn't matter what the number is, what the radius is. It could be 2, 3, 4, 5, 6, any number in the world. It could be any number in the world, but it'll always be cos square x plus sine square x. It'll always be 1, right? And we don't, and also because I gave the example of cupcakes, right, in part 2. That is why the part 2, this thing was very huge. So even 2 could be a cupcake unit, even 3 could be a cupcake unit. In that video, we, took, for example, 300. 300 was a unit, right? We could take any number in the world and that could be 1 unit. And thus, because of that very ratio, that very thing, this always will be like this, right? Because it's a unit. So we have a new this thing called the SAT preparation for people who want to give the SAT. Yep, we have this also. So in trigonometric function, we'll add this. Oh wow, we didn't add any notes in this. Aha. We'll do it now then, right? We have learned enough on this topic that we can make very summarized notes. We can make very pure notes on what we have, the what we have the most doubts and what we'll forget very easily. On that we can make notes. What students will tend to forget is why this will work for all circles. So first we'll make um, what we'll do is we'll highlight this. We'll highlight this. Yeah. So in this, a square plus b square equals to 1 sine cos square x plus sine square x equals to 1. So how do we add that? So how are they connected? How will it work for all um, triangles? Sorry, for all circles, right? With different radiuses. How it'll... Yo, what happened? For circles with different radiuses, because a unit could be any number existing. Cupcake example. Cupcake example, remember, right? It could be any number existing. A unit could be any number existing. Thus, this works. This looks like India ka map, no? The yellow one. I'm so sorry, my yeah. I'm a little sick. That is why my voice is like this. And we also in the in part three we've understood why this all is there, why all of these things happen, and why these things happen, and why this thing happens. We just learned that, right? So, this could you find the answer to this? Hmm. This is quite easy though. So what we have got to do is what is cos square? Cos square is um how do we change it to cosec square, tan square, and all of that? We cannot change it to tan square, right? Then what do we do? So what is sine square? Sine square is from 10th ka formulas. If you want me to make another video on 10th ka formulas, we'll surely do that, or I'll list a video, but it's in Hindi. Yes. So sine square, sine is basically tan by tan by sec square, right? And cos is 1 by sec square. Yeah. And 1 1 is sec square by sec square, sec sec square, secant square, secant square by secant square. Is tan square by secant square, cos square by secant square, sine. So we take all of these values and put it into this one. We put it into this one, and we get this. Easy peasy, baby. So basically, that was our idea, and how we get this. This has a similar idea behind this. Uh, I would like to leave this to you because I've solved one. So now we'll solve this table. So sine, how is it 0 here at 0 degrees? We just learned here, right? It's 0 at 0 degrees. And if cos equals to 0 and sine equals to 0, 0 or 1, it will be 0 or 1 always. Or if it's 2 pi also, it will be 0 or 1 if it's 360 degrees. 360 degree and 0 degrees are the same thing, right? They have the same points. So then what is pi by 6? What is pi by 6? 180 by 6. What is 180 by 6? Tricky question. It's 30 degrees. Pi by 6 is 30 degrees. So it's 1 by 2. How is this 1 by 2? How are we getting these values? Trigonometric values and functions. Thus we have the following table. How are we getting this table? So you weren't able to find the values, right? But you were able to find the values for these ones, right? Pi by 2 for quadrantal angles, remember? Right? I'll tell you a secret. Even I was not able to. We will perhaps learn, more about this, slowly here Here we are learning more about this. And perhaps we will, when we keep learning, we'll have more idea on this, right? Awesome. Meet you in the next class.